Hi everyone, the question is the number of continuous functions f having domain 0 closed to 1 closed and codomain all real values satisfying the condition integral 0 to 1 fx whole square dx equal to 2 times integral 0 to 1 fx dx is. So here a bit of intuition may go, okay, ultimately it is in a way, let's say fx is positive throughout, let's say, then fx whole square dx 0 to 1 integration, it is like area between y equal to fx square and x-axis as x varies from 0 to 1, and integral 0 to 1 fx dx is area between y equal to fx and x-axis as x varies from 0 to 1. So this first area is supposed to be twice of second area. Intuitively you may feel okay, there should be, since there's just one constraint that fx should be continuous, there should be many such functions existing. Let's explore it mathematically. So here I can take this right hand side to left hand side, that means this right expression to left hand side, given that they have the same limit 0 to 1, I can club them like this. So integral 0 to 1 f square x minus 2 fx, and here this feeling should or this thought should strike, okay, hey, let me complete this square, let me do plus 1 minus 1 dx equal to 0. So here you have integral 0 to 1 fx minus 1 whole square dx is equal to integral 1 dx, which is essentially as we integrated 0 to 1, it is 1. So so again, at this point itself also, if not earlier, here it should clearly, you should be able to see there should be many functions fx such that this equation hold, integral 0 to 1 fx minus 1 whole square dx being 1. Yeah, that means very intuitively you can feel there should be many such functions. But still, let's explore further. Let's say, and let me consider fx minus 1 whole square as such. Yeah. So here it can very well be just 1, because integral 0 to 1 dx just now here we have done turns out to be 1. So it can very well be 1. That means what? That means fx minus 1 can be 1. That means what? Fx can be 2 throughout, and it is a continuous function. And or fx minus 1 can be you may say minus 1. That means fx can be 0 for all x in this interval. Or you may further try thinking in terms of algebraic expressions whose integral 0 to 1 gives you 1. So first thing that may strike is what? X, but then x integration is x square by 2, and when integrated from 0 to 1 it will end up giving you half. So that means instead of x you should be taking 2x, so that the integration becomes effectively x square, and as we integrate from 0 to 1, the value you get is 1. So that means what? That means fx minus 1 can be either plus or minus under root 2x. Or you may say fx can either be 1 plus under root 2x or 1 minus under root 2x. So here itself we have got 4 functions. There can be many more such functions. You can again for simplicity's sake you can think in terms of algebraic functions like 2x and all. So here can I take x square? But for x square it is x cubed by 3 is the integration, and you'll end up getting 1 by 3 as the final value of integration when you integrate 0 to 1. So you will take 3x square, isn't it? So you can very well take 3x square, so to speak. So here fx minus 1 would be what? You may say plus minus root 3x. Yeah, let's say, yeah, because x is anyway positive. Why? Because you are integrating from 0 to 1. Yeah. So here fx is what? 1 plus root 3x or 1 minus root 3 x. So here itself 1, 2, 3, 4, 5, 6, 6 functions I have just shown you. So definitely there are many more such functions, and D is the correct answer. Thanks for listening.